Hello, everyone. Welcome to the class. Welcome to the webinar. Before we begin, can I see by show of hands if you can see my slides and you can hear me? Just raise a hand, or otherwise, thank you, Sean. Guys, Zaryab, okay, Andrea, thank you very much. Okay, guys, today's webinar is on the screen. I'm Mikhail Vladimirov. I'm the Director of Curriculum Architecture at Web Edge Solutions. And in today's webinar, I would like to touch on some of the operational aspects of using Splunk for data analytics. It's an excellent platform, and many people have expressed interest in it. Splunk has been around for quite a long time, and I believe that many of you have worked with it in one way or another, or at least you have heard about that system. I posted a link to this slide deck in the chat window. You can copy it and download for your own use. So this webinar will last for about maybe 40 minutes, 45. I would like to take your questions as we go. So the way to do it would be best to put your question in the chat window. And that would be probably the easiest way for me. I will be manning this webinar by myself, so I'll try to get to your question as it comes to my attention. And okay, so let's get started. We will introduce Splunk as a series of products and additions, and then we will quickly cover some of the capabilities of that system for data indexing, searching, and visualizations. The original creators of Splunk, it was a while back, in 2006 or 7, around the time, when they were asked a question, so how would you define your product? They said, quite frankly, that they were thinking about having a Google capability for log files. And that's probably a little bit of a stretch, but in essence, it is. So Splunk is a data-centric platform. They collect data from a variety of sources. They perform data indexing, and then that index is exposed to consumption by data engineers, business analysts. Yeah, so there was a question if you can post the link. Yes, I did that. Mohammed George, it is in the chat window. Open the chat. And actually, what I can do, I can actually also post it here. Okay. So in essence, that's what Google does for the rest of the world, right? So they collect data, they perform web crawling, and then the data that they have collected, that big web table sitting on that big table, they perform indexing, page ranking algorithm, and what's not, and then essentially they expose their findings for search. And they don't do visualization, but you can easily combine the results returned visualizing and getting a picture for those words. Splunk is very versatile when it comes to understanding a variety of data formats. If you remember the definition of big data is all about 3 V's, like volume, variety, and velocity. So Splunk really addresses squarely the variety of formats. You can also handle big data, like large volumes, if you create the specially organized cluster of indices. It's an advanced topic, but out of the box, you can start using Splunk for indexing on a single server. In addition to the traditional weblog files, CSV, JSON, they also understand all the Windows event logs formats. They can also act as a socket server and get feeds from TCP, UDP sources. So it's a great system which essentially in one place gives you storage and indexing and searching. And they're trying to find their own niche. So Splunk is positioned to address your day-to-day operational data analytics needs. Two main products are offered by Splunk. It's Splunk Enterprise and Splunk Cloud, which is software as a service solution currently running in AWS environment. So they are very similar in capabilities, and both products give you what was promised on the first slide. So data collection, search, visualization, a variety of use cases in many data engineering and generally IT operations. By the way, you have to be aware when you make a decision to move to the cloud, which is probably one of the trends that we are observing, is that there is not immediately obvious item related to total cost of ownership, which is related to the amount of data persisted, because AWS charges for data stored, and it's pennies per gigabyte, but when you start talking about per month per gigabyte, if you start moving towards larger volume ranges such as terabytes and petabytes, then your bill would definitely go up. So that's one of the things that you should be aware. Even though it sounds very appealing, kind of just pay for what you consume, but data storage is a big factor, and you have to be aware of that. Splunk additions the Enterprise, Splunk Cloud, and Splunk Free. Splunk Free, it's a scaled-down version of Splunk Enterprise, which has, I would say, a modest, they have reserved a modest amount of features. I would say maybe 70 to 80%, but it definitely is not ready for production. It has a cap for how much data you can ingest per day. It's half a gig. It's a modest log file, but it will get you started. And the way they currently position it, that you start with Splunk Enterprise, and after a period of, I believe, around a month or 2 months, they essentially give you an option to downgrade to Splunk Free, which is a community edition, a great tool to continue investigating, or to purchase an enterprise license. Everything starts with data onboarding. How to get data in the system. For that, Splunk gives you a number of channels. If you look at, there are 2 tiers. The first tier at the top of the screen gives you the whole vista of data sources that you can use to get data from. You can get data from cloud. You can get data from a variety of operating systems, as well as they're currently trying to position themselves as a platform for security analysis, for fraud analysis. Right, so the lower tier is something that you can start using right away. It's more for local on-premise type of data onboarding. You can upload files from the local file system. It's a very straightforward process, kind of a drag and drop type of thing. You can do monitoring. You can set up specific ports that Splunk will start listening on and retrieving data from Windows instrumentation feeds, HTTP feeds, as well as TCP, UDP. And data forwarding, which we will discuss as the last set of topics in this presentation, deals with the way where you cooperatively extract data from a particular source, and then you will use that forwarding agent to direct that data feed towards Splunk indexer. So as you see, they pretty much have that 360-degree touch or reach to all known data sources, and that's where they really shine. So when data gets onboarded, we're not going to talk about this because it's a very straightforward process. That has been simplified to the point that you cannot get any simpler. The next step, which happens automatically, is that your data gets indexed. Splunk takes machine data, log entries, TCP, UDP feeds, and it assigns every record a timestamp. So it can be extracted from the record itself. Splunk is very smart to recognize timestamps in whatever format they are, and then try to convert this into kind of an additional dimension to your data, which you can use for time series analysis. So essentially, it treats every data record, every row, any entry in a log file as an event. An event is usually associated with a timestamp, right? And the Splunk Enterprise Server, which performs indexing, in this role, it becomes indexer. So indexer essentially is something that performs that heavy lifting for converting raw data into an index. They use the backend key value store. They use MongoDB and a number of infrastructure components which allow them to effectively perform indexing, and that index is made available for searches. Whenever you start scaling, when your demand for data increases and you kind of segueing into the area of big data in terms of volume, at this point in time, you need to start thinking about distributed or federated Splunk indexing and searching. So for that, you need to get enterprise license, and you will be pretty much ready to process big data. Data searching, that's the next logical step. When you get the data, you need to start offering analysts, power business users, some way to interrogate the indexes. And for that, Splunk comes with its own search processing language, SPL, which cleverly combines the ideas of Unix pipes and SQL semantics for data aggregation, such counting records, grouping data, finding minimum, maximum. It's a great idea, and many systems, I guess, start copying, just mimicking that logic. If you, for example, look at, if you're familiar with Power BI from Microsoft, that's my personal opinion. I haven't, it's just, I might be mistaken, but what I see in terms of query M, they're pretty much kind of in one way or another, they just, it's the same idea, very productive. And in addition to that concept of aggregating data from the concepts offered by Unix pipes and SQL, they also offer a variety of functions or commands. And they also have things like coming from machine learning. You can perform clustering using k-means, if you know that algorithm. So it's just fantastic. When I first saw it, I just thought to myself, that's just incredible. Essentially, you've got your raw data that comes in, and you index it, and then you can, without any other additional systems, like a satellite service, machine learning or data science type of processing, they all expose that that index for applying machine learning algorithms. Essentially, that's where they're moving. They have started adopting this slowly, but it looks like eventually that would be a big merger between the indexing and searching capability plus machine learning on top of that. Right. What's interesting is that they support auto-completion, command auto-completion, coloring of those tokens, and it's just greatly facilitates your operational work, so your velocity becomes incredibly high. So data searching, this slide shows a couple of screenshots of what you can see when you start doing search. So let me highlight a couple of things. So we're talking about two log files. Actually, it's one log for the same log file. Let me change the color. Orange would be good. Yeah. Essentially, you can see here an abbreviated, kind of a shortened version of the log file. This is a HTTP log file. There is a get operation. There is a time step. Essentially, just one-to-one copy, which shows HTTP error, object not found, the size of the page, and what you can do when you start using that search window. Essentially, it gives you a number of records available for observation. And let's say you are interested in retrieving all the requests for the that were made as GET as opposed to POST, or maybe looking for the error. Maybe you support various formats, HTTP 1.0 or 1.1. Also, maybe the agent who is your prevalent user. Is it a mobile device, or is it people using Windows platform? And for that, what you do, you start just clicking on that particular token of interest, maybe the URL, and then it would give you an option. The system will give you an option whether you would like to include or exclude, add or exclude that parameter. And all of a sudden, you will be able to create visually a query that would return you the results that you need. You can also remove the search results if you are no longer interested. Okay. Here is a modest example of what you can do with Splunk search query. So let's say we do it manually. Again, there is a window for entering that command. You need to specify the source. So when you onboard your data, you will have a chance to give it a name, or it will use it by default, depending on the type of the file and the file name. So the source essentially it's a pointer to that distributed index that you have for all the artifacts related to this data source. And then you would use that pipe, which is borrowed from Unix. You can do count. Stats, it's a way to flip from the command mode into that aggregation mode. And then you can just type in English-like free-form queries. In our case, date, weekday, Monday through Friday. It's just reserved when you ingest a log file, that log file would be parsed, and there would be a number of tokens, named tokens, kind of a keys from the dictionaries that the system will associate with a particular file format. And you will be able to have very narrow, fine-grained access to every element of the whole raw data. So the whole command should read as follows. So we would like to perform a count of all the statuses, which is an HTTP status code. 0404 where it doesn't have resource or page is not found, and we would like to find it for every day where we have a day, weekday after Tuesday. So the system, as you see, it's quite fluid, and after probably 10 or 15 minutes, you become productive. The list of those functions, of course, is incredibly high, but you would probably use just a subset of those, maybe like a couple of dozen, maybe a dozen of those commands, and you will be immediately productive because auto-completion, like for example, if you type in starts, automatically the system would recognize that you want to switch into that aggregation mode, and it will prompt you for in the drop-down for all the available option statistics that you want to collect in this particular command. So if you would like to compare SPL with SQL, here is side-by-side comparison. So for example, selecting everything from a particular table and applying that predicate where values in column A should be between 1 and 9, it would be transformed, it would be functionally equivalent, the functional equivalent would be as follows. So we've got the source and column A, system would automatically recognize that this column A belongs to table. And you see there is no and, there is no between. The system goes from left to right, and you can put in and, you can put fields. There is a number of things to help you get started, but after a period of time, you start using the direct, no-nonsense type of query. A more advanced select statement with grouping, where you would like to find, let's say, average sales, where sales are below 10,000, and you would like to find those averages in groups of months. So that's what it would look like. It's not the most optimal one. You can further simplify it, but generally, you probably got the idea that it would be piped. You would specify the columns that you would like to retrieve, and that would be, by the way, syntax is very similar to what you would see in SQL. So it's by month. Now, not exactly, but it's very close. You can think of this as kind of a dialect of a particular language. Okay, so and data visualization is the last items that we would like to discuss. It has Splunk has data visualization capability built in. So whenever you after you have performed maybe initial analysis, just making sure that you have ingested the right data and the columns and the keys, what you would expect it, then the next step would be the logical step to perform like exploratory data analysis, the EDA. And at this point, there is nothing more straightforward that to use data visualization. You can build pie charts, histograms, distribution of density, different gauges, and a variety of scatter plots. Generally, the point is it takes some time to get around that very, I would say, whenever you see visual kind of the concept borrowed from Excel, you start thinking, you start learning how to make sense of that visual, as opposed to maybe they should expose some sort of a data visualization API, kind of like Seaborn or Matplotlib and other systems used in data engineering. So this is just nonsense for me, because whoever designed it, they have their own kind of a view of what you want to do. Just give me the API. I'm talking about non-business users. Business users will definitely prefer that, but for me, I would like to have access to programmatically build that structure. Probably there would do this. Currently, I don't think that they have this capability, but programmatic access, let's say maybe they would wrap it up in some sort of a pandas API and then expose it through Matplotlib, things like that. But still, it's quite powerful, easy to use after you have kind of practiced yourself. And that's what you have as an outcome of this exercise. So data visualization, what we are doing, we're trying to find how many requests were in each category. Those HTTP requests, we've got GET and all other requests. And we just want to understand if we pretty much use our website for viewing, kind of just read only, or people are uploading some information and just generally big kind of a picture, sort of an executive summary of that. You can move your mouse over a particular segment in the pie chart, and the system would give you some additional statistics, some values that would give you a drill down view of some additional insights. So the last topic that we are going to discuss, and again, guys, feel free to ask questions as we go. I don't see any at the moment. So Splunk forwarders, those are the components or agents that you need to install on every server where you would like to collect data. So that agent would be forwarding, that agent would need to be configured. It's just a flat configuration file. You specify the port and the IP address of the index server, and you initiate that processing. Essentially just a feeder of the data. You can collect data locally from a particular directory, from a particular file, and essentially just a remote collection of raw data. And the indexing server would be accepting. You need to establish that secure connection between the forwarders and the index server. And here's the generic slide figure which shows how things are combined. As you can see, the only, I guess, insight that you get here is that you can get data using the forwarding agents from a variety of sources. So functions of Splunk forwarders are listed here. So you would collect the data, and what's interesting, you also tag metadata. So when that file arrives to the index server, it's not just raw format. It also has some metadata helping the Splunk index to create an index without overlapping or clobbering out data from similar sources. You can also configure throttling and buffering to avoid overflowing Splunk, data compression to help you relieve the indexer from doing compression in place, and SSL security. So whenever you don't have the trusted environment and you would like to give some assurances to prevent man-in-the-middle attack, then you'll be fine. So there was a question, how would it make sure that it will not overwrite existing data? It's not going to overwrite, actually. It's going to append the data. So it will use the same, if you, for example, have a main index, indexing is a way to start with giving a name to the data source. So when you use the same set of source and source type and host from the same machine, data would be added, appended. Pretty much you would be updating the index, right? So in order to prevent it, you need just to give it a different host, and the host would be something that would prevent data overriding and clobbering. is there a way to display count and percentage on charts? I believe so. If you go to this screen, I haven't explored it in details what you can do, but I would expect that you can, I guess, apply this this orientation. Definitely, percentage-wise. If you do the mouse over, if you can see, essentially the system would automatically provision some sort of count. For example, at the last the pie chart below gives you that count and the percentage. So showing that GET accounts for about 94%, 93.75. Yes, I believe. Yeah, I guess there is a way to label labeling. What you're referring to, Brandy, is just labeling, and that labeling could be done. As you see that label GET, I guess in some way you can probably do it. Again, I don't know this, and I personally, whenever I see things like that, it just gives me, I would say, I understand that you have to learn something that you could have achieved with programmatic access. So I come from the data engineering background, and for that, I'd rather use something which exposes programmatic access, and I believe they should do it. It would be one of the to-do list, one of the recommendation kind of a wish list. So the question is, are these all different servers? Will be a single index, or each will have their own individual index for them? Yeah, the system would, in terms of splitting the index, is built on a single, I guess, instance around key value pair, and they use MongoDB. So all those things, they should be, I guess, associated with the same indexer. So essentially, there would be kind of a federation of indexing capability across multiple indexes. Is Outlook email a possibility source of data Splunk that it can capture? I'm not sure about this. Definitely, there would be a way to connect to the Exchange server, right? That's what I believe, Phil, you are referring to, right? Or the Exchange server, if they don't have it. Maybe, yeah, what I can tell you, I don't know for sure, but one of the capability is add-ons. Add-ons is a way to configure an additional data source. So if you don't have it, it can be esoteric, very rare source, but there is a market for this, and but that's not going to be free, right? You would need to purchase this, and there would be plug-in, and those data sources, you can create your own, and I'm pretty sure that someone would had come up with this request to be able to connect to Exchange server. Yeah, if out of the box, it doesn't support it, that's for sure. But if you go to the catalog, to the marketplace, you will be able to find one. Yeah, there is a question, can Splunk process multiple? Yeah, it looks like it's always just popping up. Sorry, I missed that. So now you asked, can Splunk process multiple files at the same time? Example, 100 users have 100 different log files for each user. I guess the system would try to allow you to do that, but I'm not sure about 100. It would probably be overwhelmed. The system would be overwhelmed, but if you go with the modest number of concurrent connections, I believe they would support it. Probably they would go around maybe single digits, maybe 5 users, without overwhelming the system. And just kind of you got me thinking. So if you got 100 users, like sessions in the system, I would say that this is, if you are sysadmin of the Splunk server, you shouldn't be allowing this from happening. You should prevent it. There should be some sort of aggregator, and that aggregator would be that throttler, that big aggregator. It's kind of an API, kind of a management. You would expose your functionality to that particular node, and that node would actually just collect the raw data, and then it would use some sort of a scheduling. So bombarding the system with 100 users, 1,000 users, whatever, it's probably not the right way to architect your solution. I would say, yeah, it's a possibility. You can see for yourself, but most likely it's not going to fly. Okay, let me see if I have missed anything. Is there a list of data sources Splunk supports? Yes, you can find it from the documentation. It's just a long list. And one of the challenges speed with when querying a big log file. Is there any improvement made to do a recommendation of how querying to make it faster? Definitely, that would be a challenge. And even though they put indices on those indexes, but still, if you have large data files, probably if you have a specific, I'm referring to you, Serge, to your question. I believe what needs to be done, if you have a situation where you have a big demand or need to process large data as quickly as possible, then probably, and as Splunk, the setup that you currently have doesn't you allow to do that, you probably need to start looking for another solution. That's just a given. Or probably you need to split your data in one way or another to allow the subsetting so that you kind of onboard data per groups, per month, per year, without essentially you're just breaking up that data monolith. One way I would suggest is to use Hadoop. Hadoop has, in addition to a number of things, good things, the storage, which allows you to distribute processing to store data in split format, and then use probably Apache Spark. So Spark would allow you to intelligently process data in massively parallel way, where your terabytes worth of data would be spread across a cluster of machines, stored on HDFS securely and fault tolerantly, and then you would just use Spark, and Spark is extremely fast. And terabytes would probably be, you would be definitely better off to process data in this way, because in case of data analytics on Splunk, I think that they don't do this type of arrangement under the hood. So definitely up to a certain limit, probably several gigabytes, you can process data in this way, but beyond a particular threshold, and you should have a policy, some sort of governance rule that would say so the files beyond the particular threshold should be directed to that data lake, not to the Splunk. So this link didn't work for me. It worked now. Nice. Great. Thank you. No problem. What are dashboards in Splunk? How alerts can be triggered based on seeing specific keywords and logs. Dashboards, essentially, it's just a way for you to collect the sources and your queries that you would like, as well as visualizations, to kind of to combine those and make them cohesively, like semantically cohesive. Specific keywords, yes. There is a way to raise an alert. This is a feature of the Enterprise Edition. So whenever a particular thing, you just need to configure that alert to react to a particular thing. So you designate an email address or other destinations, so you can consume that. Yeah, they support it. So generally, what I see is that you cannot use the same tool for all the practical cases, use cases. There should be a set of tools, and you should have a toolbox and experience working with a variety of systems, so that you can always fall back on something which is most suitable. So Splunk definitely is great for operational data, but as I said earlier, out of that 3V of big data, they support variety with flying colors. In terms of volume, they're not there, and they originally are not positioned to be there, because usually operational log files, they're a matter of gigabytes, and the problem is just that there are such a big variety of those log files. So that's how they position themselves. So when they say Google, it's not Google at scale. It's Google about what Google does: data onboarding, indexing, ranking, and then offering that searching capability. So definitely you need to use different tools. For example, if you really don't have currently on-premise any system to process large data, take a look at Databricks Community Edition. They give you just entry-level free access to evaluate what you can do with Apache Spark in the cloud. And that would be probably the easiest way for you to get started. Spark, you don't need to learn Scala or Java. As long as you know Python, Python would be your friend. And you'll probably pay like single digits, maybe double digits amounts, maybe per week or maybe per month, and you will be able to process the data. They support visualization; it's built in. Lots of things can be done, and that will be the tool for the size, for the volume. Okay. Writing from a Kafka topic into Splunk using Splunk connectors versus writing to files that are forwarded to Splunk, which is better for performance? No, I guess you have to investigate it. I cannot answer this question. You need to set up and see for yourself. Definitely, Splunk as a client to a Kafka topic, it would probably work nicely. But if you want to use Sync Connector, no, I cannot answer this question. It would be very nice if I would have answered, right? No, I cannot. Does Splunk have a built-in REST API endpoint? I think that Splunk SaaS has it. No, I haven't. I'm not sure the enterprise. That's what we were looking at in our research. So built-in, no, I don't think so. But SaaS probably has it for remote access. Any more questions, guys? Okay, guys, that's all from me for today. Hopefully you found something that you can use in your everyday work. That's all for today. Thank you very much. I wish you all the best. Okay, bye-bye.